Okay, so let's get started. We're going to be taking a look at setting up a flex fuel based tune and how the flex fuel strategy works in our model fuel equation mode for the Link G5 and G4X systems. Now, a flex fuel based tune requires an ethanol content sensor. So we need to wire in, typically it's going to be a GM Continental sensor to our Link. We need to get that configured correctly and make sure it's actually reading properly before we do any actual tuning within a flex fuel strategy. So the first thing we're going to take a look here is how to set up an ethanol content sensor and making sure that it's accurately reading, and then go through some of those settings. It's important to get all the little details right for that content sensor. Then we can turn on the flex fuel tuning feature, and we're going to talk about how that all works. Now, this is going to assume that you're going to be tuning with petrol fuel first. This is going to assume that you have everything dialed in from cold start, cranking fuel, post start, warm up enrichment, normal volumetric efficiency table, transient fuel, fuel injection timing, charge cooling coefficient, all of that. All of that has been taken care of on petrol fuel already. Then once we know it's 100% solid, the calibration is good, we can go in and start to drain the petrol fuel out and put in ethanol. And then we'll find that the Link is going to do the work in the background for us in this model multi-fuel mode. And it's going to essentially tune out the fuel for us. We don't have to really do much of anything. And what we're left with to be able to actually calibrate and tune is going to be cranking fuel, spark timing, and if we're turbocharged and we're using boost control, also varying the boost based on the ethanol content. So we have some specific things that we have to set up and pay attention to for working with this. The very first thing is going to be setting up our ethanol content sensor. Let's jump in and take a look at that real quick. What we're going to do here is move to our digital inputs. We can find ethanol sensor is right in our window right here. The source, we have to point it where we've wired the sensor. In my case, I have a GM Continental sensor. Now, what I'm working with here is a kind of a cheapy knockoff sensor, just so I could put it on my test bench. We're going to find that the sensor is actually not going to be compatible with the Link. Some sensors will have this problem where they're not outputting and broadcasting a fuel temperature reading. So not only do they broadcast the ethanol content, but they broadcast the fuel temperature. And why that's important when we're in the model mode, specifically the model multi-fuel mode, tuning in flex fuel, is that the Link needs to know what the fuel temperature is going to be when we're turning on the model multi-fuel option. If you don't have a valid fuel temperature reading, it'll calculate the fuel density completely incorrect and skew your fueling. So we want to make sure that we have things correct, and we're going to take a look at how to verify things. Again, I have a sensor that's not compatible with the Link here on purpose, so you can see what this is going to look like and some of the details we need to pay attention to. So let's go to our source. We're going to click Digital 2. That's where I have my ethanol content sensor wired in. Now, immediately when I turn it on, we're going to notice that the Digital 2 here ethanol sensor is showing active and that the ethanol content is showing 10%. Now, I have pump gas from the local gas station here in the vehicle, and we're going to find, in this case, that it is 10% blended fuel. So meaning we have 10% ethanol, 90% petrol fuel, pretty normal here, again, common for the United States. Worldwide, that's going to probably be different for you, but here in the United States, it's pretty typical. So the other things we have to go in and configure here, there's a pull-up resistor. This typically has to be set to on for most all of the GM Continental flex fuel sensors. We also have our active edge. Now, this is what we need to pay attention to. The active edge should be set to rising. Now, I'm going to go ahead and do that real quick. The rising option here doesn't change the reading in the ethanol content sensor, but what it does do is change your fuel temperature calculation coming from the sensor. So it's going to look at the way it interprets the fuel temperature output reading within the content sensor's output. If you have the edge wrong, it skews and completely has the fuel temperature incorrect, which will then calculate fuel density incorrect, which will then really drastically impact your fueling calculation. So looking here under the active edge, it's set to rising right now, which is the way it should be set. If we jump here into fuel and then we go here, just turn on the logging real quick to record, we're going to notice if we go all the way over here, fuel temperature is showing 200 degrees Celsius. This is a completely skewed reading, even though I have that edge set to rising, which it should be, because my particular flex fuel sensor is a knockoff Continental and it is not going to be compatible with the Link. This is a problem with the model mode. You can make the sensor work if you're in traditional mode, because technically speaking, Link is not going to take into account what the fuel temperature is going to do. If you set up your tune for flex fuel in the traditional mode, things aren't as highly math modeled, so it's not looking at fuel density and the fuel temperature. So this is a problem here for the model mode, but I wanted to just demonstrate this here for you so you can see exactly what you need to pay attention to. That's the first thing I do. I turn the sensor on, I configure it real quick, I double check, does the ethanol content look reasonable? Yes. Okay. Does the fuel temperature look reasonable? No. Well, I have some kind of a problem. It's usually going to be the sensor itself. If you have a content reading and it seems valid, but the temperature is incorrect, that sensor is not going to be good. All right. So now we know what to look for. Obviously, this is incorrect. This is important that it reads accurate. When you have a cold engine, so key on, engine off, you can compare it to your air temp or your coolant temp reading. So that should be pretty similar in terms of that reading for perspective's sake. Okay, so let's go jump back in here to a digital input and let's talk about this a little bit further. There is a frequency filter. Now, most ethanol content sensors I've ever worked with, in fact, all of them I've ever worked with, they're going to be the GM Continental sensor. I have never had to apply a frequency filter, but we can apply a filter to the signal coming in. If it's a little bit erratic or kind of skipping around a little bit, you're noticing it's not going to be relatively smooth in its reading. So I'm going to keep it off because I typically don't ever have to use that. Then there's an ethanol sensor fault value. If for whatever reason the ethanol content sensor faults in your operation, whether it's on petrol fuel or you're on flex fuel, it's going to default to the value that we find right here. Now, if it defaults to 85%, that's fine. That's going to probably, if you're on petrol fuel, make your vehicle start to run pretty rich. If you're on ethanol, it may not be ideal, but it'll at least keep the engine running without having some kind of a completely skewed ethanol reading. So if the sensor fails and we didn't have the failsafe set 85%, and let's just say it was set at 10%, you would run lean when you're working with ethanol fuel in your fuel system. That's definitely not ideal. So it's better just to be more precautious, even if you're on petrol fuel, and set this to 85%. That way, Link is going to calculate from this default value as the engine is running and you have whatever ethanol blend in your system. And we also have a couple additional things. Ethanol sensor lockout value. This is
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.